Come here. There you go. Just gave him a little Gator Chow biscuit treat right there for him. He loves those things. Hi, buddy. So what we're going to talk about today is some really, really cool stuff about like basically crocodilian genetics and similarities, and like how similar are alligators to crocodiles, comparing that to how similar humans are to other mammals, and then also talking about it on like a evolutionary timeline kind of thing. So we're gonna go through some numbers on here now. These are numbers that I have had to look up. Just, full disclosure, obviously I am not an evolutionary biologist, and I am not the person doing the actual research. So I'm going to quote some of these numbers as I have read them. So if anybody out there may know more about these subjects and wants to correct me, by all means. I'm just trying to make it make sense off of what I have learned myself through reading other people's work. So let's get into it. So alligators and crocodiles are often thought of as being the same thing by the layperson. A lot of people like gator, croc, whatever, it's the same thing. What's the difference, right? Now, if you follow my channel, you probably recognize there's a pretty big difference between alligators and crocodiles. We've done videos discussing some of those. Just to hit it really quick, some of the physical things to watch for: alligators have that more round, broad nose. Crocodiles have a more narrow, pointed nose. Alligators are darker, crocs are lighter. And then there are over 20 different species of crocodilians in the world. And if you were to actually look at it that way, each one could be different from the next. So like an American crocodile that has never eaten anybody in the history of the state of Florida here in Florida, compared to like a Nile crocodile that eats like 300 people a year in Africa. Very different kind. So even among crocs, a croc is not a croc. Depends what kind of croc you're talking about. But if we were to just go with crocodiles and alligators, is where it gets really cool and really interesting. So these are all included under the umbrella of crocodilians. So Crocodilidae, so they're all alligators, crocodiles, caiman, gharial. They're all considered crocodilians, right? So crocodilians is not exclusive to crocodiles. It does include the alligator. So crocodilians as a whole evolved around 230 to 240 million years ago. Think about that number for a second, because you got to really consider that dinosaurs went extinct 65 million years ago. Like, oh my God. So yeah, they share a common ancestor with dinosaurs. They evolved and lived alongside dinosaurs. So their common ancestor would be the archosaurs. So there were archosaurs, and then that split off where you had crocodilians, and then dinosaurs into birds. So, and then reptiles as we know them now came much later. So an alligator is more closely related to a bird than to a lizard, which is so crazy to think about and like trying to make sense of that. Because a lot of people look at them like, oh yeah, it's like a water lizard, right? No, actually, again, he's closer to a pelican than he is to one of the lizards you might see in the wall behind me. Really wild to think about, right? So alligators and crocodiles. So crocodiles as we know them today evolved around 84 million years ago. Alligators as we know them today evolved around 33 to 37 million years ago. Now, why I say as we know them today is because throughout this timeline, there have been many different iterations of crocodilians. We often call them living fossils, and we often say that they're the same as they were at the time of the dinosaurs, which in some ways is somewhat true, but in other ways is not. And if you want to get technical about it, that is not a correct statement to make, because there have been several different iterations, like Caprisuchus, which was a more terrestrial crocodilian that would run after prey and does not look like what we have today. And so there were different ones that branched off that were more marine crocodilians that only exclusively lived in the ocean. There's a lot of different ones that don't exist anymore that did go extinct, but the same body type that we see here today did exist alongside with the dinosaurs. But again, there were different ones that popped up along the way as well. So I'm kind of getting the weeds on that because I know some people are sticklers for that kind of a thing. And it's really cool. But as we know them today, right? So alligators, as we know them today, around 33 to 37 million years ago. Crocodiles, as we know them today, around 84 million years ago. And then crocodilians, 240 million years ago. Really cool stuff to think about. But then if we compare that to humans, that's where it gets really interesting, really crazy, is like you are closer on the timeline to a rat, to an opossum, to a pig, to any mammal, name anything. You are closer to that thing than he is to a crocodile on that timeline. Isn't that nuts to think about? For something that we as humans generally consider to be basically the same thing to most people, I mean, you are closer to literally a mouse than he is to a crocodile, even though superficially they look very, very similar to most people, right? And that just speaks to the idea that this has been a very successful body plan throughout evolutionary history, and they haven't had a need to really change. And although there are differences, yes, very close to the same body plan, especially if you were looking at, like, again, a human and a mouse, and you're like, what? Those things are closer in time than those things, even though they look basically the same. So let's talk about the genetics then, since on the timeline, that's pretty mind-blowing, right? The genetics are also pretty mind-blowing. Alligators and crocodiles share about 93% of the same genetic material. Meanwhile, or the same genes, rather, same genetic material. Yeah, we all share the same genetic material, but the same genes, right? So 93% of the same genes between alligators and crocodiles. Casper, come. We'll try to get back over here so it's not just me sitting over here talking. Come here, buddy. So they share 93%. Humans share about 98 to 99% of the same genes with a chimpanzee. And we recognize chimpanzees as being drastically different than humans to most people. Casper, come. And then, like orangutans, they share about 97% of the same genes to a human. That's still a huge similarity. What would we consider to have a 93%? Come here. So to make the analogy here, right? So if alligators and crocodiles share 93%, what do humans share 93% with? Well, when I was researching this and looking it up, we share about 90 to 92% of the same genes with pigs. So you are sharing 90 to 92% of your genes with a pig. That's why you can do a heart transplant with a pig and a human. That's why that stuff works, right? So that's pretty darn cool, pretty interesting to think about there. Now, let's see. So 93% right there. What about some really weird stuff? What about a banana? That's a really fun one that I like to bring up. So we share about 50% of our genes with a banana. So really cool, really weird, and just shows how interconnected all life on Earth really is, and the amount of similarities that we have with all these different organisms. Really cool stuff. Really kind of a mind-bending topic to try to consider and think about, especially when you start thinking about things, in terms of 10s, 20s, hundreds of millions of years of similarities or timeline differences there. It's really crazy stuff and really hard to actually wrap your head around. But also, since we're on this topic, alligators and crocodiles are kind of my main thing, but what other animal group is also one of my favorites to work with are sharks. And if you guys followed me for a while, I used to run shark diving trips as one of my businesses. I dove with over 20 different species of shark, great whites, makos, tigers, bulls. You guys know sharks are older than trees? If we're talking about that timeline thing again, like literally sharks evolved and existed on this planet before trees did. That is insane to wrap your head around. Pretty sure the number was 430 million years ago when sharks evolved. What? That's insane. And then if we're just talking about here in Florida, me and George were talking about this, we like to go fossil hunting. And so we go fossil hunting, we'll find megalodon teeth here in Florida. And those, I think, are around 20 to 40 million years ago is when those actually existed over Florida. So the shark's teeth that we're finding are in that time range. Now, those are right in the middle of the state of Florida. You can find these shark teeth. It's crazy. So in that long ago, Florida didn't even exist at all. And then we also find fossilized alligator teeth and also various other extinct animals. Alligators aren't extinct, obviously, but we find crocodile teeth in North Florida, and I'm pretty sure those are from a crocodile species that is extinct and is not the same as the American crocodile that we have here now. But then we'll also find liptodont fossils, which are a giant armadillo. I found a dire wolf tooth, which is so cool and crazy to think about. I found mammoth vertebrae. I found a piece of a mammoth tusk in Florida. Florida's got a really cool history, but what you're finding in Florida is relatively new because Florida didn't exist 100 million years ago, So it's really cool and interesting and complicated and confusing to think about, but I love talking about this kind of a topic. Unfortunately, I don't know that much about it, so I can't go into any further detail, and I've already probably said some things that were already wrong, so I'll give you that right now. This is, again, I'm really bad at remembering numbers, actually. I had to memorize this before we did the video. I'd be I had to say it over and over again because I'm really bad at remembering numbers, but it's still such a cool topic to talk about, and I love fossils. I love thinking about these terms of millions of years of time, and then these crazy genetic similarities and differences in how similar we are to something as they may not be to other things. It's so cool to think about. But I find it fascinating. Hopefully you guys did too. Let me know in the comments. And anybody who knows more about this topic than I do, which is I'm sure many people, you can also feel free to correct me, because I'm sure I flubbed some of the facts I was just trying to give, but I did my best on here. So let me know what you guys think. As always, like, comment, share, subscribe, all that stuff, and we'll see you all next time.